All right, I'm back. Thanks so much to the commenter, Ashcan. That's the kind of stuff I need to keep going on this. Sorry, I missed a session. I missed making videos yesterday. Thanks for the encouragement. So let's make another video. It's going to be part three. Um, so that's right here, information files and uh, device files. I'm going to do a quick check on the audio. Looks like the audio capture is good. I am recording, so let's get right into it. Information files and device files. The commands lspci, lsusb, and lsmod act as front ends to read hardware information stored by the operating system. This kind of information is kept in special files in the directories /proc and /sys. These directories are mount points to file systems not present in a device partition, but only in RAM space used by the kernel to store runtime configuration and information on running processes. Such file systems are not intended for conventional file storage, so they are called pseudo file systems and only exist while the system is running. That's interesting. Let me read that one more time because these directories are mount points to file systems not present in a device partition, but only in RAM space used by the kernel to store runtime configuration and information on running processes. Such file systems are not intended for conventional file storage, so they are called pseudo file systems and only exist while the system is running. That is very interesting. Okay, so I'm going to read this. Let me just finish reading this paragraph and then I'll read the whole thing again. The /proc directory contains files with information regarding running processes and hardware resources. Some of the important files in /proc for inspecting hardware are /proc/CPU info. So this lists detailed information about CPUs found by the operating system after the system has been booted and that information has been loaded into the volatile memory, the random access memory. So you're getting this information from the RAM. The next important file for inspecting hardware is, and I'm confused because like this word, this language for inspecting hardware. Well, I guess it makes sense because like the hardware is going to load in information about itself into that volatile memory, the RAM, and then you use that information to inspect it. So the real time running, uh, the what is a word that they used here? Running processes, uh, runtime. Runtime. That's a big word. So like these are running pieces of hardware that load information about themselves into uh, these pseudo file systems that only exist while the system is running because they provide uh, runtime configuration and information on running processes. When you shut the computer down, you won't get uh, the same kind of if you were to just take a snapshot of what's on the disk. Well, I mean, if you were to look at the disk at all, you probably wouldn't see this because this is not coming from the non-volatile memory that you have on solid state drive or mechanical drive. It's coming from the random access memory that's like in those memory sticks. Okay, so slash proc slash interrupts a list of numbers of the interrupts per I/O device for each CPU. Slash proc slash I/O ports lists currently registered input output port regions in use. Slash proc slash DMA lists the registered direct memory access channels in use. So I'm going to go to my home lab, which I'm still connected to here. I'm going to do a refresh of these things. So the first thing we're going to do is list all of the um, PCI uh, devices. So any device that's plugged into a PCI port on my motherboard, we're going to list here. And now if we talk about ports, so here I've got a HDMI switcher. So we've got all these different ports on here. We've got HDMI ports, stereo port, um, something to plug the power into, like this service kind of USB port. So on motherboards, they have additional kinds of ports besides just that. And one of the ports is a PCI port. And the PCI port connects to other components of the motherboard through something that's called a bus. One of the ways you can think of a bus um, is kind of like it's the equivalent of like here we have a cable. So it's kind of like the opposite of this, where instead of plugging it into a port here and then having this be what transfers the data, it's like the port, instead of having this wire here, it has a bus. You plug it into there, into the other part, and then the different sockets on the motherboard all communicate with each other through something that's called a bus. Oh, and looks like I've got a random something in my motherboard or in my. Well, that's good. That okay. Okay. So let's. Yep, I'm gonna review. So that was a review of bus. That's something I didn't have a very clear understanding of in my own mind. So that's cleared up. That's good. So here's everything in those PCI ports. Got quite a bit. Let's take a look at what's in the USB slots on my home lab. Not not as much. And one thing I don't know is, are these just looking at the actual slots, whether they're filled with something or whether they're not, or are they only listing slots that have things connected? And if the slot doesn't have something connected, then it won't list the slot, and you need to use another command, maybe like ls usb -a to see like all the slots. You can always do a --help. So like maybe you need to do a so here's the verbose. It shows for each. Okay, so here we have a cannot open device. Cannot open device. So I think perhaps it is the case that it just shows all the slots whether there's a device connected or not. So if there is a device connected and functional, it should be able to open that device. So to see which slot actually has a device in it and which do not, um, I would think that this would be a way to do it. And you know what? This makes sense because I don't think I have any USB drive plugged in uh, to it. So one thing I could do is just go quick plug in a USB drive. I kind of want to keep moving on though. I feel like I'm getting a little bit distracted here. Let's try it for the PCI because I know that there are things plugged into the PCI. but it could be the case that there's no, there's not going to be an example of what it looks like when there's a, like all of the PCI ports are full. Oh, here we go. So here's a good example. So we've got um, yeah, so we've got kernel drivers in use, kernel modules. So like these are actual devices. So this here's the RAID controller. Not sure what that is. Here's a wired internet card. Um, yeah, here's all the networking components on it. We've got a storage disk. There should be multiple storage disks on there. Um, or like some sort of storage disk. Yeah, storage disk controller. The storage disks themselves plug into like a SATA socket, not a PCI, but like the controller that will go into the PCI. Okay, so yeah, here's examples of what it looks like when devices are actually plugged in to the PCI sockets. We'll see there'll be a kernel driver in use. That's if you, and I'm not sure what the difference between that is. Let's go to ChatGPT quick and really drive that point home because that was a point of the last lesson. So plug that in there. And what is the difference between the kernel driver and the kernel module in this context? Question mark. Okay, and I'm still sorry. I'm still getting used to.
It
Okay,
appears there
and
may be some confusion in your query.
yeah.
Can you
So
please?
stop. Yeah. Okay, so I'm going to open a new one. I'm not going to worry about that so much and say, in this context, what is the difference between kernel driver and kernel modules? So ChatGPT isn't always the most reliable, but I find where it goes awry, it's usually um, better than just getting nothing. It leads you down the right path typically. So, in the context of Linux and Unix like operating systems, a kernel driver and kernel modules are both components of the system, but they serve different purposes. Kernel driver, this is the software component that allows the operating system to interact with a specific hardware device. Kernel module, a kernel module is a piece of code that can be dynamically loaded and unloaded into the kernel upon demand. So a kernel driver functions as an intermediary, translating the general instructions from the OS into commands that the device can understand. When you see that, it means that the oh, and this is a good example as well. PCI ports are kind of like how USB ports can be USB A, USB C. There are different kinds of PCI ports, and one of the kinds of PCI ports is the PCI Express port, which is a smaller uh, version right there. Okay. And here's the bigger, more standard PCI port. Kernel modules extend the functionality of the kernel without the need to reboot the system. For example, device drivers can be kernel modules. When needed, they are loaded into the kernel and provide the necessary. Okay, so in simple terms, a kernel driver is a type of kernel module. Okay. Um, in Linux, what is the difference between a kernel module and a kernel driver? Yeah, I'm not sure that I'm trusting that. So I want another. Okay. Okay. So it's complicated. They were probably correct that, um, yeah, a kernel module is not okay. So the biggest takeaway from this, and then the thing I need to be the most careful of, because I think when learning something, the worst thing you can do is come away from something believing you understand it, being really confident in your understanding, but having your understanding being wrong. So I did mention in a few prior videos that I thought it might be that because this can be plugged into a um, Windows or a um, Linux operating system, it has both kernel drivers and kernel modules. And because this driver is the term that we use for Windows, um, the driver is what it would use if it were on a Windows system, but the module is what it uses in a Linux system. As far as I could tell from what I saw in ChatGPT and what I saw looking at Stack Overflow, completely wrong. Just forget it, forget it, forget it. The real answer is complicated and perhaps not entirely relevant for now. Okay, so that is these two commands. Let's review the third command. So the third command is all the modules. Okay, and then we can get more info on the module by doing mod info, which is not listed there, but it's something that I remember figuring out in the last video. Okay, now let's take a look at what's in proc and sys. Okay, quite a bit in proc, quite a bit in not as much in sys, and looks like it's more directories. You can use AL here. The first thing to do for any new command in Linux or any command you're not 100% familiar with, dash dash help. All commands should have dash dash help, and it will tell you what you're looking for. It could be a bit difficult to understand what they're saying, like this ls option, dot 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 file dot dot dot. Um, Especially with something like this file, because you need to feed it the file. Uh, and to do that, you need to know the difference between an absolute path and a relative path. And this is the biggest thing that people struggle with in learning Linux, in my opinion. An absolute path is so if we were in a city, let's say we're in New York, an absolute path would be the full address of wherever you want to go in New York, with the zip code, with the um, full street name, with the uh, with the city. We know we're in New York City already, but include that in there. So let's take a look, just to really drive this home. Let's say a full address format, and take a look at some images of that. So uh, yeah, so these are all here, um, something that could represent a uh, like the concept of metaphor for an absolute path of a file or a folder in Linux. It would be all the information about that. Yeah, so these are really good examples. These could represent absolute paths. Now let's use that same analogy and let's think about uh, a what a relative path is. So a relative path would be, oh, it's in Chinatown. It's 3 blocks down to the left. It's on Willie Street, even though the full name of the street is Williamson Street, and you'll never see Willie Street written anywhere on the street signs. Those are examples of absolute path. So just like in life, you can be overly specific and give it a full address in Linux, or you can just shortchange it and say you're almost there. It's just on the next block. You can do that in Linux as well. So let's try. So another key command is this pwd present working directory. So this gives a absolute path. So let's do ls, and yep, we've got a bunch of things there. So let's change directory to this GNS3 directory. And let's do it in two ways. The first way we're going to do it is by specifying the absolute path. All right, and now we're there inside that directory, and we did it by giving it the full address. Even though our present directory is already here, we already know we're there. We gave it to it anyway, and it knew how to get there because we gave it every little tiny detail it possibly knew to get there. Okay, so now let's go back to the previous directory, which you can do with this dot uh, shorthand. And let's go into there again, but let's use the relative path. There we go. And the same thing happened there. We didn't need to specify this because it knows the present directory already, and relative to where we are in the present working directory, there's no confusion about what this is. Now, let's say we had another user, um, and both of those users had this in there. So let's say the other user was something like ASDF. So if we were in this directory here and we wanted to access this folder that belonged to the ASDF user, and then we did it like that, that's not going to work because absolute to our present working directory, that will be the folder that belongs to myself. So in order to get to the one that belongs to ASDF, in this case, we have to provide it with the absolute path, which would look something like this, which would look like this. Okay. And in this case, that user does not exist on the system. But that's an example of why you need to learn the difference between the two, because you could accidentally access a file that exists in the relative exists relative to your current present directory, but isn't the actual file you need because somewhere else on the system it has the same file name, which is valid because it is part of a different uh, folder hierarchy. It belongs to it's relative to a different present working directory than the one you are in now. Um, Another thing to understand as for why absolute versus relative paths are necessary is, let's say we have a program that that we can run called my program. Okay, and then if this program were found, what the program did was it did a CD into this GNS3 folder. So we could write the program in two ways, the way we did here. So we could write it to where it gives us the absolute path, or we could write the program to where it gives it the relative path. So if we write it using the absolute path, we don't know where this program is going to run. So it could run on a system that doesn't have this absolute path. But if we write the program using the relative path, we can give instructions to people to set up their system to be able to run this program, and they can run it at a present direct working directory that has everything needed to run it. So it has the GNS3 folder relative to the present working directory. So it's able to change into that folder. And that's important because the new system, new users, new everything, if you just give the exact address to something and you're expected to be run on different systems, that address is not going to be valid because you're in a whole new neighborhood. So absolute path instructions, you have a program that's designed a specific way. Absolute path instructions are too specific and don't allow it to be run, to be portable, to be run on other systems. So that's a reason why relative path um, is so powerful, is because you can write your instructions relative to that program, and you don't need to worry about where exactly in the file system folders and files are. You just need to know where they are relative to how your program is designed to run, which you can have instructions or requirements for installing the program to make it so that you don't need to concern yourself with uh, the particulars of a system, because it's the program's place within the system is all the instructions in the program are going to be relative to the present working directory of the program in the system. So yeah, that's another important thing to understand, uh, is that absolute and relative um, paths for files and folders each have their own um, advantages, uh, and it's important to know when to use one or the other. You need to use a absolute path if you have multiple files and folders with the same name. You need to specify exactly which one you want to use, um, and you need to use relative paths uh, if you want your program to be portable. And of course, there's more than that. This is a complicated long thing. This is just kind of a understanding I have that I know for people just learning this can be really particularly tricky. So, because you'll see a lot of people doing things like they won't do this present directory command, and they'll be like, "Oh, I'm trying to cd into," or like say I'm here in the home, and they say, "Oh, I'm trying to cd into the GNS3, but it keeps saying that it's not found." Well, I know it's there. It's lying. I can see it there uh, if I do like can I do like oh, I can't. But if I do a command, I can see it there, but it's lying saying it's not there. It's like, well, it's because you're specifying a relative path, and relative to your present directory, it doesn't exist there. And then the other important thing to understand is it's case sensitive. So we see it there, but it's lowercase instead of uppercase. So if I wanted to get to this uh, from this present directory, oh, it doesn't exist under there. It's just now here's a fun one. Uh, why did this not work? So the reason this didn't work is because I gave it an absolute path that was incorrect. So I'm trying to change directory into this. So where does this exist on my system? It exists relative to my present working directory, which is slash home. So I can get into it by doing cd, going like that. Now you can see the mistake I made. I tried to get it to it going cd forward slash like that. So what is forward slash? Forward slash is an absolute path. It's the top level root uh, of the file system. There's nothing before that. It's the very because all the files and folders are nested within other folders. So it's the top level folder where nothing is nested. It's not nested under anything else. It's the very top level. So like the tree, it's like the trunk of the tree. So what I did here, and the reason why I wasn't able to go in there, is I gave it a absolute path, and I said, let's change directory to the tree trunk of the tree, the very top high level parent folder on the system, and then within that, the gposh folder. We can see that does not exist there. So it's true. There was no such file or directory. So if I wanted to change here using the absolute path, we see my present directory was slash home, so it would look like this. There we go. And now I'm in that folder using the absolute path. I go back to that present working directory forward slash home, and we can see home exists within here. I can get to it using the relative path like that, because we go back relative to our present directory, we see that folder there. I cannot get to it like this because this does not exist in this parent folder. All right, so moving on, I kind of lost my place, so just refresh, and I think it should take me back there. Um, okay, all right. So now let's do some hands-on for these. So we're gonna do a list of each of those, and I'll do a list dash al just to demo that. So the other thing to know about Linux is, or about Linux file systems is you can when you're listing out files, you're listing out files that are not hidden. So you can do this in Windows as well. You can hide files and folders. Um, but the way to do it in Linux is you say so touch is a way to create an empty file. So I'm going to create an empty file. Say my empty file, and now let's do an ls. We see it right there, my empty file. Now I'm going to create another file named dot my empty file. There we go. And now we see, oh, where did it go? We only see my empty file. Well, let's do this. Let's do cat my empty file. Okay, so didn't get an error message at all. Now let's do cat dot my empty file. No error message. Now let's delete my empty file. And let's cat that. Oh, well, yeah, we deleted it. It doesn't exist anymore. Let's cat the other one. Still there, no problem. So we'll do an ls. Where is it? I don't see it. That's because it's hidden. So to see a hidden file, you do dash A, and here it is, my empty file. So let's remove that. And that's what dash A does. It shows all the hidden files on the system, and there's usually plenty, and it makes sense to hide files just because they're automated files, like your bash history. If you're doing the version control of your files, some configuration, um, we can see, if we were just if we were not hiding any of those, every time we did an LS, we get all this garbage showing up. So to have them hidden, we keep everything nice and clean. And then if you want to go into further detail and see things that you probably shouldn't be messing with, you use that dash A. The other one, dash L, we can see a long format. So we can see the permissions of the files. We can see whether it's a file or a directory here with this D or the dash there. Um, we can see uh, the owner and the user group of the file. We can see last modified. We can see how big it is. Uh, yeah, last modified data, how big it was. So a lot more details. I typically always do the dash L just because I like to see all the details. So let's do the dash AL for the proc CPU info. Okay, well there's seems to be nothing in there. Okay, there's nothing in there, which is interesting. Oh, oh, it's a file. It's a file. Yeah, so some of the important files in slash proc for inspecting hardware are this. So it's a file. You can't. LS lists all the files in the directories. So it's a command that applies to directories. Cat shows the contents of a file. So we can use cat instead of ls. Yeah, you concatenate file to standard output. Okay, so here we go. Looking good. Audio still working. Still recording at the 38-minute mark, but I can keep going. Okay. And notice how it starts with this. We're giving it a absolute path, not a relative path. If we wanted to do a relative path, we can change directories into proc. Proc is a directory containing these files. Let's take a look at the files. There they are. And now we could do cat interrupts without the slash or anything preceding it because it is a file that is relative to this present working directory we're in here now. But let's go back home. You can just do cd on its own usually to get home. And let's take a look at that file by feeding it the absolute path to that file in the file system. And this is within the the file system. There's this is just one kind of address on a computer. There's lots of different kind of addresses. This is a networking channel, so of course there's IPv4 addresses, IPv6 addresses, there's MAC addresses, but as we saw earlier, there's also addresses of the USB ports on the motherboard, the PCI slots on the motherboard. There's also these relative and absolute paths, which can be kind of considered a address within a file system. But then there's actual addresses for locations on the actual disk itself, which if you're familiar with Python, um, you might be in a lot of beginning Python tutorials. they show that they're a long string of numbers. So there's addresses everywhere all the time. All right, so here's the I/O ports. And here's the direct memory access channels in use. We've got only one cascade. I'm curious about that, so I'm going to ask ChatGPT, say, so why is this DMA channel open? And I used ChatGPT 3. Let's ask you again using ChatGPT 4. Okay, so it's the system's cascaded DMA controller. The DMA channels are used to allow certain hardware subsystems within the computer to access the direct memory for reading and writing independently of the central processing unit, CPU. This can help improve the overall performance of the system. In many systems, the DMA controller has two levels, hence the term cascade. The primary controller communicates directly with the CPU, and the secondary or cascaded controller communicates with the primary controller. The cascaded controller can manage requests from several devices at the same time. So the presence of the cascade in your output here, direct memory access, output from your volatile memory, so your runtime information, simply indicates that your system has a cascaded DMA controller and it's currently being used or reserved for use. It's a normal part of your system's operation and isn't typically cause for concern. It doesn't necessarily mean a particular device is actively using DMA at this very moment. Note, this file is considered obsolete in many systems. Modern hardware, especially in these architectures, which are typically using UETF instead of BIOS, uses more advanced methods of DMA like bus mastering, which do not require the use of these specific DMA channels. As such, the block DMA file may not show meaningful or complete information about DMA usage in your system, especially if you're using such hardware. All right, looks good to me. Files inside the /sys, which is a absolute path directory, have similar roles to those in /proc. However, the /sys directory has the specific purpose of storing device information and kernel data relating to hardware, whilst /proc also contains information about various kernel data structures, including running processes and configuration. Another directory directly related to devices in a standard Linux system is /dev. Every file inside /dev is associated with a system device, particularly storage devices. A legacy IDE hard drive, for example, when connected to the motherboard's first IDE channel, is represented by the file /dev/hda. Every partition in this disk will be identified by /dev/hda1 and HDA2. And we remember what this means. So this means the hard drive, uh, yep. And then this is the which drive, so you can have multiple drives in the system, drives A, B, C, D, whatever. And then within the drive, you can have multiple partitions. So this is the first partition of drive A, and this is the second partition of the same drive, drive A, up to the last partition found. Removable devices are handled by the UDEV subsystem, which creates the corresponding devices in /DEV. The Linux kernel captures the hardware detection event and passes it to the UDEV UDEV process, which then identifies the device and dynamically creates corresponding files in /dev using predefined rules. In current Linux distributions, UDAV is responsible for the identification and configuration of the devices already present during machine boot up, cold plug detection, and the devices identified while the system is running, hot plug detection. UDEV relies on sysfs, the pseudo file system for hardware related information mounting on slash sys. Note, hot plug is a term used to refer to the detection and configuration of a device while the system is running, such as when a USB device is inserted. The Linux kernel has supported hot plug features since version 2.6, allowing most system buses, PCI, USB, etc., to trigger hot plug events when a device is connected or disconnected. Let's see my Linux kernel version. How do I check my Linux kernel version? Because I just want to see how old that is. Here we go. So we're going to do u name dash r. So I'm on version 4.15. This was introduced in version 2.6. Now let's ask what the latest Linux kernel version is. What is the latest Linux kernel version? Okay, so the latest version. Oh, yeah, they can't do that. Okay, so let's do that just to the web. Um, 6.3. So mine is quite a bit out of date, which makes sense. I set this up um, years ago during the pandemic. So I'll probably do for an update. Um, yeah, my Ubuntu I'm running is still here, but the thing is, I'm purposely running an out of date system because of compatibility with GNS3. All right. As new devices are detected, UDEV searches for a matching rule in the predefined rules stored in this directory, and it's a directory. So let's list out all the files within it by feeding it the absolute path. So here's a file. Cat out that file. Um, oh, it's a directory, and we can see whether it's a file or a directory by giving it the -L. Um, oh, and it says that it's a file. So this is a good lesson in absolute versus relative paths. And if you're a beginner to Linux, this is the number one thing that's going to mess you up time and time again. And we can see I'm not a beginner to Linux, and it's still messing me up time and time again. So what I did here in this first command is I listed out all the files in this folder. So let's do that one more time. There we go. So now here's the files in this folder. Now what I did in this second command is I printed out the contents of a file with this file name. Where is that file? Well, where am I now? Let's do pwd. I'm in /home/gposh. Is that file there? Let's find out. Let's list all the files in this folder that I'm in now. It is not. We do not see a file in there with this file name. So what I did here is I tried to print out the contents of this file by specifying the file name absolute to the present working directory I am in now. And we can see that is the case. I did that because I did not specify anything before the file name. I just gave it the file name. So if the file name does not exist, absolute to my or sorry, relative, and those are really clear terms relative to my present working directory, which we see it does not, then yeah, of course it doesn't exist. So, what are two ways I can print out this file? The first way is I can give it the absolute path. There we go. And now I printed out all of the contents within that file. The second way, I can give it the relative path, but the relative path is relative to my present working directory. So how do I do that? I change my present working directory by this command cd, and then I give it the absolute path to the folder that I need to be in to be relative to this file. So to have my present working directory relative to the location of this file. And now I can do this command and give it this relative path because relative to my present working directory, the file exists within it. Now, here's where it gets a little bit more tricky. What if I were to do this? Did I feed that command cat, which shows the contents of a file, an absolute or a relative path? The answer is I fed it a relative path. Relative to my present working directory, which is not the trunk of the tree, the highest level parent directory, root directory of the system, where there are no, where it's not nested within any other directories. Relative to this present working directory, I gave it a path to this file. Absolute paths always start with the forward slash because it's the full path on the system, which will always start with that forward slash. Any relative path, uh, I mean, technically, if you were in, but even then, let's change here and let's list all the files in etc. I don't. That's an absolute path. So the main difference between an absolute and a relative file path is whether or not it starts with this forward slash. That's a clear and easy way to think about that. Okay, so as new devices are detected, UDEF search for a matching rule and the predefined rules stored in this directory. The most important rules are provided by the distribution, but the new ones can be added for specific cases. Okay, so it's a long video so far. We're almost at an hour, so I'm gonna chop it up here for now, and then when I come back, it'll be the storage devices section. Oops, we've got multiple instances of that term storage devices, so I'll include the first sentence instead. Um, that didn't work either. Okay, I'm having trouble. Let's just do. I think the comma might be messing things up. There we go. All right, and that's the end of part three of this lesson. Stay tuned for the next part where I finish reading and then I do all the guided and explorational exercises, read the summary, and read the answers. Thanks for watching and see you in the next one.